Hello, this is Brian from McKay Marine. A lot of people have been asking us about multi-beam technology with the Olex. So I'm going to go through just a short demo here to kind of explain how the multi-beam works. As you can see, if we look at our vessel here sailing out, we're coming out of a harbor and we're using the Atec multi-beam in this example to do a very wide swath. If we click on boxes, we can kind of see the spread of where the soundings are going. So again, this is one pass and you're getting a very high resolution map. So if we want to look at it with a little bit of color, you can see it there very well. The purples are the deeper areas, the reds are the shoulder areas. And again, keep in mind this is one pass going through the system. So we click on 3D here, get auto. There's our boat mapping in real time. And keep in mind, we're only here at about 7 or 8 fathoms. So the deeper the water is, the wider the swath beneath the boat will be. And if we pull back a little, you can see in this one pass how this has mapped these edges very accurately. Small objects here as well. Again, multi-beam is not a new technology, but I would say it's a newer technology to the fishery. Just because the cost has become a bit more affordable. It's not cheap, but it is much more affordable and user friendly than what it ever has been in the past. Typically with most multi-beam systems, they'd be used by hydrographers. They'd be on the vessel, making adjustments and calculations and sound speed casts and things like that. Whereas with the Olex approach, everything is done automatically and in real time to give you the most accurate bathymetry that you can get, and it doesn't require post-processing in an office. So if you look at this area here, we're mapping in 3D, but when we come down, you can see the detail that we're getting, and again in one pass of the vessel. So in almost 10 fathoms of water, we can measure across and get an idea how wide that swath is. If you look here, we're measuring about 130 meters or so across in just under 10 fathoms. Now as we come out into a little deeper water here, you'll see how the swath gets a bit wider. We can also have a look at the sonar image. This is a live sonar image showing this is the boat, this is directly beneath the boat, this is from the starboard side out, and this would be from the port side out. So as you can see, this line varies, but again, as you see it, the terrain is varying on either side of the vessel. So as far as complication of use, some people will say, well, is this difficult? If you're running a general Olex system, the only difference you would have with this, when you turn your system on, you would click on the sonar button and you would go click transmit. And you can run this on full auto. So there's no need for any adjustment. It adjusts its own gain, it adjusts its own range. All that stuff is taken care of internally by the Olex system. So this sonar image, you don't even have to see it. You just see the live map being built here. The other thing that's important with this system, this is for bottom mapping only. The beams on this system are too sharp to be used for fish detection. You may see a school of fish, but it's, picture a high definition television. A fish that looks like a blob on a traditional echo sounder is going to look like a speck on this. So it's really focused on sharp beams, and that's what gives you the detail of the bottom here. So if we look back even at some of these areas we've mapped, we can put some color coding to them, try to get an idea of, see these small areas going through. So this little area here, for instance, if I go and measure across there, just to get an idea of what type of distance we're talking. I mean, that's less than 8 meters, 8 to 10 meters across there. So we're talking a fairly narrow area, but that gives you an idea of the sharpness of this sonar. And there you go, as you see it continuing mapping. Again, very nice contour map as well. Beautiful contour map. There's really no need to go over this twice. When you come back and pass, you may pass through this area. You'll see some breakup here, but a lot of that has got to do with the terrain. If the beams can't reach over the terrain, if the terrain rises. So typically with the Atec, you can go as wide as 180 degree, which would be more so for very shallow water. But the typical beam setting is about 130 degrees. So you can pretty much expect that the width of your mapping here is gonna be about 3 to 4 times of what the actual depth is. So if you're in 100 meters of water, you can expect that you're gonna have a width measurement here of about 350 meters roughly. Again, that can vary on water temperature conditions, water currents, that type of thing. But as you see, as you're going along here, like if you're mapping out your harbor, sailing out, it's not going to take very long to do it. So again, this is kind of the highest resolution mapping you can do currently that we're aware of anyway. And this is not a recreational product. It's not priced as a recreational product, and it's far beyond the capabilities of what a recreational product can do. As you know, everybody has their new 3D little sonars from the main electronic companies. Those are a recreational product. This stuff here is survey grade. So the data you're gonna get from this, you're gonna be able to retain it, save it, improve it over time if you want, and you can get some bottom hardness with this. But I'll go through the bottom hardness in a little different video, but this was just to introduce the Atec sonar from Olex.